Mecca is one of the oldest cities on Earth. It is not a financial hub, not a technology capital, and certainly not a place people come to build flashy symbols of modern power. This is a city where time is measured by rituals, by prayers, and by a rhythm of life that has existed for thousands of years. Yet right next to the Kaaba, the spiritual center of more than 1 billion Muslims, a structure was built that defies all conventional standards. The Mecca Clock Tower. Standing 600 meters tall, costing an estimated $16 billion, and carrying the largest clock ever constructed, visible from more than 8 kilometers away. So how was it possible to build something like this without crossing the invisible boundaries of Mecca? Join Mandarin Tech as we trace back the story behind this extraordinary structure. Mecca is not just a city. For Muslims, it is the heart of their faith. At the center of Mecca stands the Kaaba, the sacred site toward which Muslims around the world face when they pray. At least once in a lifetime, every Muslim is required to perform Hajj, the pilgrimage to Mecca and one of the 5 pillars of Islam. Each year, more than 3 million people travel to this city. They perform the Tawaf, circling the Kaaba 7 times, a ritual that has existed for centuries. The journey then continues to other holy sites such as Mount Arafat and Mina, where the world's largest tent city is formed during the pilgrimage season. This massive flow of people has turned Mecca into Saudi Arabia's second-largest religious tourism center, surpassed only by oil. Tens of thousands of hotel rooms, along with logistics services and infrastructure, must be built to support this constant movement. However, building in Mecca is unlike building anywhere else. It is not simply a question of economics or architecture. It is a question of faith. A structure built next to the Kaaba cannot be just another high-rise hotel. It must carry symbolic meaning, respect the sacred space, and blend into the religious rhythm of an entire world. When it comes to scale, the Mecca Clock Tower almost defies all familiar comparisons. At 600 meters tall, it rises from the heart of the ancient city, becoming one of the tallest structures ever built. The clock mounted on the tower is dozens of times larger than Big Ben. The minute hand alone measures 23 meters in length, nearly as long as a multi-story building. The building's facade is covered with 98 million mosaic pieces, nearly 1/3 of which contain 24-karat gold leaf. At night, more than 2 million LED lights illuminate the entire structure, allowing the clock face to be seen from over 8 kilometers away. If this tower were placed in Paris, London, or Los Angeles, it would completely dominate the skyline. But Mecca is not an ordinary city. The presence of the Kaaba changes every familiar sense of scale, and that creates a unique challenge. The tower must be large enough to serve millions of people, yet restrained enough not to overpower the religious meaning of the sacred site beside it. At first, the tower was designed to stand at about 450 meters tall. Even that height would have been enough to make it the tallest building in the world at the time construction began. The problem was that once the structure was already halfway built, the ambition changed. The developer decided to increase the height to over 600 meters, while also adding a massive clock and a symbolic crown at the top. But the foundation had already been poured, and that foundation could only support a maximum load of about 82,000 tons. For comparison, a building of similar height, such as the Shanghai Tower, weighs many times more. Tearing out the existing foundation and rebuilding it was nearly impossible, both technically and religiously. At that point, the question became critical. How do you build higher when you cannot build heavier? The answer did not lie in adding more material, but in using it more intelligently. Engineers turned back to a principle that once transformed architectural history: lightweight structural design. More than a century ago, the Eiffel Tower proved that a structure could rise to extraordinary heights without massive weight, as long as the loads were distributed efficiently. Based on this principle, an ultra-light composite steel structure was designed to sit on top of the existing hotel levels. High-strength steel carried the main loads, while composite materials reduced weight without sacrificing stiffness. Thousands of steel components were manufactured in Turkey at a pace of up to about 1,000 tons per month. Every single piece was unique, individually coded to track its position and installation progress. Construction ran almost continuously, 24 hours a day. Even a small design change made in the morning had to be implemented on site by the afternoon. In Mecca, time waits for no one. If the structure is the backbone of the tower, then the clock is the mechanical soul of the entire building. The task of building it was given to a German company specializing in tower clocks, a firm that for more than a century had worked almost exclusively on church clocks with diameters of just a few meters. So when they were asked to build a clock face more than 40 meters wide, their first reaction was disbelief. Only after receiving the full technical drawings and official specifications did they realize this was a project without precedent in the history of clockmaking. No clock had ever been required to operate at heights of nearly 500 to 600 meters, where desert winds can exceed 200 kilometers per hour, combined with heavy rain, sandstorms, and extreme temperature differences between day and night. At this altitude, the clock was no longer just a timekeeping device. It became a dynamic structural element. Any vibration in the hands could generate oscillations that would travel back into the entire crown of the tower. To solve the aerodynamic challenge, the clock face was designed with a slight inward curve, allowing wind to flow past it rather than strike it head-on. The clock hands, stretching up to 23 meters in length, could not be made from conventional steel or aluminum because they would be far too heavy. The final solution was carbon fiber, lighter than aluminum yet as stiff as aircraft wings, allowing the hands to remain light enough for precise movement while strong enough to resist deformation under powerful winds. Hidden behind the clock face is a central drive system weighing more than 20 tons, manufactured with tolerances of just about 0.1 millimeters. Installing this mechanism required the entire construction site to come to a halt, because even the smallest error could affect both the clock itself and the tower structure above it. Remarkably, many of the engineers who designed the system never saw the clock operating in Mecca. Non-Muslims, they were not permitted to enter the holy city and had to place complete trust in their calculations and numbers alone. Hidden behind the modern steel and concrete frame is an outer skin deeply rooted in Islamic tradition. The facade of the clock tower is not finished with smooth glass or metal like most contemporary skyscrapers. Instead, it is entirely covered with tens of millions of glass mosaic pieces, creating a surface that is both shimmering and solemn under the desert sun. The base layer of the facade is made from carbon fiber composite panels, lightweight, durable, and capable of withstanding the harsh climate at high altitude. On top of this surface, 98 million glass mosaic tiles were installed by hand, many of them containing 24-karat gold leaf. Mosaic craftsmanship in Venice has existed for more than 1,000 years, but it had never faced an order of this scale or under such intense time pressure. To meet the schedule, traditional methods had to be combined with robotic processes. Even so, quality standards remained uncompromising. Only the most flawless tiles were allowed onto the facade, and even the smallest imperfections were rejected. The facade panels were not installed directly in Mecca. Instead, they were completed in Dubai, inspected one final time, then disassembled and transported across the desert over several days. Once on site, each panel was reassembled near the sacred area, where all construction activity had to pause during prayer times. This was not simply construction. It was an exercise in patience, discipline, and absolute respect for the sacred space in which the structure stands. At the very top of the Mecca Clock Tower sits the Hilal, a crescent moon, a familiar symbol seen on minarets throughout Islamic architecture. But here, the Hilal is more than a religious symbol. It is also the most complex and riskiest structural element of the entire project. Built entirely from carbon fiber, the Hilal became the largest carbon fiber structure ever produced. Light enough to stay within the tower's strict load limits, yet strong enough to withstand powerful winds and vibrations at nearly 600 meters above the ground. Inside the Hilal is a unique space, the highest prayer room in the world, suspended above the holy city of Mecca. From an engineering standpoint, placing an occupied space at this height was already a major challenge, but the real difficulty lay in installation. Because of its massive size, the Hilal could not be transported as a single piece. It had to be divided into multiple sections, hauled by truck across the desert, and then reassembled piece by piece in midair. At that altitude, every operation took place under strong winds, limited visibility, and almost zero margin for error. Even a slight misalignment during lifting could have led to disaster. Bringing the hilal to the top of the tower was therefore not just an engineering problem. It was the final test of trust. Trust in calculations, in construction discipline, and in the people working at the fragile boundary between safety and risk. The moment of installing the hilal was the most tense point in the entire construction of the Mecca Clock Tower. It was the instant when every calculation, drawing, and engineering assumption was put to the harshest real-world test. The crane was operating at its absolute limits, pushing both its maximum load capacity and its maximum height. High above, stronger than expected winds caused the massive structure to begin rotating slightly, creating movements that were difficult to control. At a height that makes anyone break into a sweat just thinking about it, there was no room for error. Workers had to hang from safety lines, using human strength to guide and stabilize a structure weighing tens of tons while crosswinds continued to blow. There was no backup plan, no option to lower it back down, and no ability to wait for long. Either they moved forward at that moment, or the entire operation would have to be abandoned. In the end, through precise coordination down to every hand, signal, and a bit of luck, the hilal was guided into its exact position. The wind slowly eased, and across the entire site, for the first time after hours of tension, everyone could finally breathe again. To understand why bamboo is still trusted today, you have to look at how it's actually built, something far more surprising than most people expect. Behind the familiar sheets of fabric covering Hong Kong's skyscrapers lies a construction world almost no one sees except the scaffolders themselves. Every bamboo structure rising dozens of stories begins with just two simple materials: thick bamboo poles for the main load, and thinner ones for reinforcement, woven together like the skeleton of a giant creature clinging to the building. No bolts, no forged steel, only plastic ties pulled tight by hand, forming perfect grid patterns strong enough to withstand the winds that whip through narrow city streets. Layer after layer is added from the ground all the way to the rooftop without any heavy machinery. Becoming a true bamboo scaffolder takes 3 to 5 years of training, learning how to climb, tie, balance, and even feel the tension of the bamboo through the palms of their hands. From a distance, the whole system looks fragile, but the closer you look, the more you understand how it has survived for a century. A quiet craft that holds an entire city up in the sky. At 30 stories up, bamboo stops being just a material. It becomes fate. Every scaffolder knows they're standing on poles no thicker than a wrist, tied together with knots they have no choice but to trust completely. One strong gust of wind is enough to make the whole frame tremble like their own heartbeat. What most people don't realize is that for bamboo to even reach this height, it goes through a strict life cycle. 3 to 5 years of growing, 3 months of sun drying, and it can only be used a maximum of 3 times. But no matter how carefully the poles are selected, humans remain the weakest link. Every year there are slips, poles that snap without warning, and tiny accidents so quick they're almost invisible, yet enough to take a life in seconds. Not as loud or dramatic as the 2025 fire, these tragedies happen quietly. But they reveal the constant danger hiding behind every single bamboo pole. So if it were you, would you dare to stand at that height for about $18 an hour? After everything we've seen, all the risks, all the close calls, you'd think bamboo would have been banned from modern construction. But here's the irony. The very things that make bamboo look outdated are exactly what give it an edge steel or aluminum can't touch. Bamboo walks onto a job site like a silent economic warrior. It's so cheap that any project, from an old apartment block to a $1 million skyscraper, can put up scaffolding without ballooning the budget like metal would. It grows everywhere in southern China. It's light to transport, easy to replace, almost as if it were made for a city that never stops building, like Hong Kong. But what keeps bamboo alive after all these centuries is a kind of efficiency no other material can mimic. It's light as air, letting workers climb, tie, and hang hundreds of feet above the ground using nothing but their own strength. Its flexibility lets it absorb shaking, impacts, and sudden gusts between buildings, moments where steel can sometimes snap. And behind all that is one of nature's own tricks. Bamboo is the fastest growing plant on Earth, stretching up to 60 centimeters in a single night, reaching 40 meters tall, built from long vertical fibers that act like natural cables. That structure makes bamboo harder to snap sideways than steel of the same weight. Once you understand that, you realize bamboo isn't a relic of the past at all. It's a natural solution that modern construction, whether it likes it or not, still depends on. The Mecca Clock Tower was created to stand exactly where it needs to stand and to serve the purpose it was built for. In a city that has existed for thousands of years, where every rhythm of life revolves around sacred moments, this structure becomes a rare point of intersection between faith, science, and engineering discipline at the largest possible scale. And perhaps it is this quiet presence that makes the building truly special. It does not chase attention or seek to constantly break records, yet it stands firm as an anchor, both in physical space and in meaning. If you enjoy infrastructure stories where engineering is not just about building higher, but about serving something greater, subscribe to Mandarin Tech, turn on notifications, and join us as we explore the hidden stories behind the world's greatest structures.